By the way, this lesson is also online. We're having some time trying to get all of our lessons onto the website because everything got switched because of Windows 7 and everything else. So it's taking a little extra time to get that set up. But if you look up a lesson 5 from previous years, it will be fine. It'll be much the same, not the same examples, but be enough to help you figure out how to do the lesson. Anyway, so I call this trig equations 2, the sequel. All right. This should be better than the first one. It's not like the matrix, or the matrix is very good, but the sequel was not so good. All right. So trig equations 2. Last time you did questions like this, right? Let's see. And then I'm going to show you what the new part is today. We solved an equation like this. 3 sine squared theta. Maybe I'll do it with cosecant. Cosecant squared theta minus 2 cosecant theta minus 15 equals 0. Okay? And let's say it says this, though, instead. And I'm going to show you how this is different. Solve for all real number values. Okay. Is there somebody there? No? Oh, there's somebody. Okay, solve for all real number values. So, what did we do? What were the steps in solving a trig equation? Do you remember? Solve the equation. Good. So the first thing we're going to do is solve, in this case, for cosecant theta, right? We're going to isolate that. How do we do that with this one? Factor, good. Cosecant theta. Cosecant theta. Don't forget the equals 0. Things that multiply to 15 that I can make a 2 out of.
5 and 3.
5 and 3. The 5 will have to be negative. The 3 will have to be positive. Right? Therefore, cosecant theta will equal negative 3, or cosecant theta will equal 5. Right? Step 2 is to find the reference angle. But we can't do that with cosecant because we don't have that on our calculator, right? So what are we going to do?
The opposite of cosecant.
Yeah. We're going to use, it goes with the other letter, right? Remember I said the C goes with the S, so it's one that starts with the S, sine. So we're going to do sine theta will have to equal negative 1/3, or sine theta will have to equal 1/5. Agreed? And now we're going to go inverse sine of 1/3. Notice we ignore the negative. And we're going to do the inverse sine of 1/5. With your calculator on radians, right? So we do that. 1/3, I think, is 0.3398. And 1/5 is 0.201. 0.20136. What's that? Well, because sine is the reciprocal of cosecant. So if cosecant is 3/1, sine would be 1/3. You flip them around, right? Okay? And then what's step 3? Remember what step 3 is? What do we do with those reference angles? What's that? Yeah, we do this, right? We do this thing. Agreed? We draw the angles where they belong. Okay, Tanner? So where do I draw this one? Where sine is negative, right? Yep, so I have to draw it in 3 and 4. Well, because that's what happened here, right? We were solving for, who asked the question? Oh, okay. Because cosecant was negative, therefore sine would be negative. Yeah, we're finding both solutions. We're finding this branch leads to 2 answers, and this branch leads to 2 answers. Okay, good. And so here we'll go where sine is positive. Good. Everybody okay with that? Okay. So, and then what's step 4? Final answer. So that's knowing that we're going to have to add pi plus 0.3398. We're going to have to do 2 pi, subtract that. We're going to have to do pi, subtract this here, right? And here that number is correct. So the way that you state your final answers is you should write down each of them. So we have theta equals, well, that's the easiest one, 0.20136. And then theta equals, we're going to do pi subtract the answer, which gives 0.294, 2.9402. Remember I said to always write it to 4 decimal places. And then we're going to do pi plus 0.3398, which gives you 3.4813. And then the last one is 2 pi subtract that. And it's 5.9433. Okay. Is everybody okay with that? Well, except it's not 180, right? Because we've got to use pi, because we're in radians. Yeah, this is, here you're going to add, here you're going to subtract, right, depending where you are. Everybody good? That's what we did last time. Now today, remember last time I said you had to check where do they want the answers? Do they want them between 0 and 2 pi? Do they want them where? Right, so you're going to have to check whether you want all these answers. Well, here's what they're telling you though. They want all real number values. Okay? So this is the concept for today. What if they ask for all, I'll do this in blue. This is this principle. Watch this, people. If 0.20136 is a solution, right? So would if I went around the circle once and went to that same spot. We call that coterminal, right? So because I didn't say I wanted the answer between 0 and 2 pi, I want all the answers. I have to think about how I could represent all the answers when I go revolutions around. You get what I'm saying? Sometimes people see it more in degrees. If this was 30 degrees, of course, 390 would also produce the same value, right? Because it's the same angle. Okay? Well, what is a revolution around the circle? 360, or in radians, it's 2 pi. So that's what we're going to do. We're going to add 2 pi to each of these numbers. Make sense? Right? That would produce another answer for each of them. Do you agree? Good. Excellent. You could keep doing it any number of times, right? So, good. Except we say pi k. because x is a variable, so we're going to say k. But can k be any number?
Yeah.
No, what number couldn't it be?
Whole number.
What's that?
Whole number.
Any whole number. Very good. K couldn't be 1.7 because then we wouldn't go all the way around, would we? K could be once, that would be one revolution. It could be two, that'd be two revolutions. It could also be negative one, couldn't it? Because we could go the other way and we'd still get back to the same spot. So that's K is an integer. So as long as it's an integer, like 1, -1, 2, -2, 3, -3, then we're okay. Okay, so that's what one of today's major things is. You're going to do exactly what you did last time, but you're going to add 2 pi k to the answer. And you have to say this little thing. Whenever you introduce a variable, you have to tell me what that variable is. You can't just throw down k and assume that I know what it means. Is that okay?
Wait, so what do we have to do with k?
You have to then tell me that k is an integer. And this is the shorthand way of doing it. It means k is an element of the integer set. All right? Some textbooks will say z as well. Z is the universal symbol for integers. Okay? So if you see that, it has to do with different languages. Are we okay so far? All right. So that's the new topic. You're adding 2 pi k. So here's the question people often ask. When do I do it? How do I know? Well, today, because today's assignment, but how will I know otherwise? Well, as long as I don't give you a span at the beginning, like as long as you don't see this 0 to 2 pi or 0 to 360, if you don't see that in there, that means I want them all. Now, there's different ways I can say I want them all. I can say I want all general values, all real number solutions. I want all the real numbers. Those are all different ways of asking the same thing. But if you don't see a 0 to 2 pi or a 0 to 360, you know you've got to add the 2 pi k. So that might be our step 5 then. Do I need to add 2 pi k? And that you should be able to see right at the beginning of the question, right? It's worth 1 mark. So even if you did everything else wrong, and you added 2 pi k to your answers at the end, and said k is an element of the integers, you get 1 mark. Okay. Yes? Good. You could say, usually they don't ask in degrees, but you would say add 360k. Makes sense, right? All right, now I'm going to show you the second thing about today that's different. Working with k theta. Maybe I'll say n, because then you're going to think it's an integer. I'll say n theta. What if they stick a number in front of the theta? So for example, suppose this is your question. Solve for all general solutions let's see. Now that this one. I want to see what I want to do here. I want to do this. I'll figure it out here. Okay. There we go. Oh, I missed what I wanted to do though. Shoot. Sorry. Sorry, I'll get it yet. Okay, there we go. All right. I'm trying to do too many things at once. So you see what's different here is they had the 2 theta in there, right? So there's a number in front of the theta. There's a couple of questions like that today. Now here's your strategy. If you can remember this. You ignore the n right until the end. Good. And at the end, you're just going to divide your answer by n. And the last step is dividing the solution by n. Okay, so that's the key here. Okay, so we do exactly what we did before. Pretend the 2 theta is not there, or 3 theta, or 5 theta, or whatever it is, right? It can be anything. So we're going to factor first. So step number 1, solve for sine. In this case, it'll be 2 theta, but it doesn't really matter. So we go like this. The thing is, you have to write that 2 in there all the time, right? You just have to keep it there. All right, I need things that multiply to 2 that make a 5, so this has to be a 2, and this has to be a 1. Right? So that's negative, that's positive. Agreed? Factoring thing, I know it's trouble for some people, that's what we do first, right? Okay, and then we would have now sine 2 theta equals negative 1 over 3, or sine 2 theta equals 2. Right? So we're just ignoring the 2 theta, pretending it's like just a theta or like an x. So that means step number 2 is now to find the reference angle, right? So we're going to do the inverse sine of 1/3, which we did before is 0.3398. Again, you notice I ignore the negative, right? And we're going to do the inverse sine of 2. Can someone do that without a calculator? The inverse sine of a number over 1. That means the opposite side has to be longer than the hypotenuse. Can that happen? No. No solution. You would get an error on your calculator if you tried it. Right? It's also, if you remember the sine curve always goes between 1 and negative 1. Right? So this is saying, where's the sine curve 2? It never is. All right. So now we continue just like we did before. Number 3, we put this 0.3398 in the same spots. Right? Where sine is negative, right? Because it was negative at the beginning. Right up here. Because of the negative sign, we draw it in quadrants 3 and 4, right? Okay. Then number 4, we state our answers. And we did this before, right? What were they again? That corresponds to 3.481 and 5.943. 3.4813. One three. Okay, we're okay with that? Everybody okay? And it also said it wanted all general values, so what do we need to do? Yes. Plus 2 pi k plus 2 pi k, where k is an integer. Right? That's because of the general value thing. We're okay with that? Good. So we do this as well first, and then the very last step, so I guess this is step 5, I guess. And then the very last step is we divide all by n. In this case, 2. Okay? So that means theta is going to equal 1.7406, and theta will equal 2.9716. Right? Dividing it by 2. And then we also divide this by 2 though as well. So now it becomes pi k. You could write it like this if you wanted, but it'd be simpler just to write like that, right? But either would be fine. The important thing is that you're dividing both things by 2. Not only the answer, but also the revolutions. Because now it won't take as long to go around, because I'm multiplying the angle by 2, right? If I add 180 degrees, but multiply that angle by 2, I'm really adding 360, right? This will also be cut in half because I'm multiplying the angle by 2. Right? I only need 180 degrees to make 360 because I'm multiplying the angle by 2. If my original angle I'm putting in is 180, multiplied by 2, it's 360. Right? So the thing that you got to remember, Taylor, is that it affects this value as well. You divide both things by 2. Is that okay?
Yeah.
So those are the 2 concepts for today. It's just like yesterday. You're going to add 2 pi k to your answers at the end, so just that last step is different. And then the other thing that's different is if there is something in front of the theta, you keep writing it in all the time, but at the end you just divide by that number that's in front of the theta. Okay? Good. It's assignment 5.